So here's the image of the run cap. The top wire, wire 3, goes through an AC cap. In this case, it's actually coming off of wire 2, because I've got the connections reversed. That's what's set up right there. There's no AC bulb, goes through that bridge rectifier right there. And the output is going into the thing to be measured here on the voltmeter. And I've got horrible lighting, but it's 216 volts DC. So, without the AC, without the bulb in series, and then this is slightly manipulatable by adding or removing a little bit of voltage up here. 216 volts is coming out of that bridge rectifier. My input is at, I don't know, we'll call it 0.5, 0.7 amps at 120 volts off the mains going into this. So it's tuned so that it's right in a little hot in the virtual circuit, which is the wires 2, 3 is the exciter cap voltage, wires 1, 2 is the mains voltage, and then that voltage is the DC voltage. DC voltage coming out of this fwbr, full wave bridge rectifier, 218 volts. And that is being current limited by these 3 caps right in there. That's 10 UF plus 2 UF plus 2 UF, so it's 14 UF. While the main capacity on the 7.5 horsepower motor is the 7 UF, 20 UF, and a 1 UF, which is that one there. So I'm looking at 28, 29 UF roughly. Half of that is what's roughly in series going to the AC legs of the bridge rectifier, which is what's netting me that 216, 218 volts output DC. So the question is, does that make that input amperage go up or go down when I'm shorting it out to a battery? So that's the end of this vid. I will make a second vid where I've got it wired up so that I can close the switch and have it go into a battery. But I'm a little bit leery having 217 volts shorting into a battery. So I think yeah, we'll just see how that goes, I guess. Hopefully it doesn't blow up the battery.